Hey, hello guys, welcome to Lecture 8. Today we're gonna start our first lecture of Iterables. So um, we will talk about list and mutability for this lecture. And the C++ version at DVC is in Computer Science 110 and 165. Let's get started. So today we will finish the first three goals. So what are the literables? And how many kinds of iterables and what is a Python list, and what thing in C++ is similar to Python list. So we'll talk about this too during the spring break. And yeah, let's get started. So iterables. Mm, what are iterables? Iterables are kinds of simple data structure or basis to store, get, or generate data, and everything inside the base can be accessed with a loop or iteration. So it's basically like a data structure, and it's very easy to access. And also you can use iteration to access all the members in the iterable. So um, because it can be accessed by iterations, so it is called iterable. And how many kinds of iterables are there? So we will talk about Python list for this lecture, and we have string, tuple, Python dictionary for next lecture, and we have iterator and generator for our first lecture of iterables. So okay, let's get started to Python list. So in Python list, suppose I have a sequence, for example, Fibonacci sequence, starts from 0, 1, and then the third one will be the sum of the first two members. Um, okay, well, 1, 1. So I want to store so many numbers into a variable, like store all of them into a variable. What am I supposed to do? Like we only have like integer that can like store a number to a variable at a time. And how can I store all of them? So how can I store all of them? So we can use a Python list. So Python list is like you can create a list by creating a pair of the square bracket and include all the elements into the bracket. And then you bind that to a variable with an equal sign. So for example, I have this one. This one equals a square bracket in which we have 0, 1, 1, 2, 3, 5, 8. So I store so many numbers into the variable named this one. And this itself is a list. A list contains a lot of members, and they can be of same data type, or they can be of different data types, and also have list two, 1, 2, 3, 4, 5, 6. So as long as you have the square bracket and you create it, and it will be a list. And these elements are positionally sensitive. So what does it mean? Like that means that you in order to access the data, and you must know the position of it, and the position um, cannot be changed like casually, because you access the data according to its position, kind of. So the first one is zero position. Suppose I have this one, like 0, 1, 1. But like in programming, in list and array, we start with 0. So which means that uh, the first place, like the very beginning of the list, we call that the zero position, because we count everything starting from 0. So if I want to get 0, like so 0 here, so I have to say 0, this one 0, and then return 0. And the first one, this one, we access that with the position 1, and another one we will access that with 2, and this access with 3, 4, 5. And how about the last one? Suppose I don't know like how long is the length, how long is the list. Like suppose I don't know the last index of this list, so I will access it with minus first, like -1. So the last one, if I want to have A, the last one is -1 and position. So list 1 and -1. Yeah. And it return 8. Yeah. And this is the list in environmental diagram. So we have the object list like from 0, 1, 1, 2, 3, 5, 8. And for the in the global frame, we have the variable name list one. And this is actually a pointer pointing to the object list. Yeah. And so how to get the size of the list? Like how long is the list? Like how many elements in the list? We use the length of the list, which means like length of the list. So length of this one will be 7. We have 7 elements in there. And because we start everything from 0, so which means that the last index of the length of the list will be 6. So the length is the last position index plus 1. Like because in math we start everything from 1, like to count how many. So but in Python or in programming languages, we start with 0. So the last one will be one less than the actual length. Yeah. Okay. So to get the size of list and modify list, and we call this mutability. So we have talked about the list, and maybe you want to modify, maybe you want to take out something from the list, or maybe you want to add something to the list. So how am I supposed to do? Yeah, so we use some functions. Uh, I mean, I guess some methods. Yeah, that would be better. We use some methods to do the mutability. Yeah, so the methods we have pop. We have remove, append, extend, and insert. Okay, so these 5 are the methods to modify lists and to achieve mutability. And we will talk about each of them from our next slide. And the first thing is how to access them. We use dot operator. We will talk about more about dot operator in OOP. But obviously we have to use it here. So like suppose I have to do like uh modify this one and pop, suppose this one. And this one is the operator, which means that we want to use the method because you think actually this is an object, a built-in object in Python, and this can be the member function of the list object. So we can like which is the property of list. So we can use this built-in property to modify our list, and we have to use dot operator. Like in English, this is called yeah like a period. Yeah, we actually use a period in programming language. We use dot. Like this is a dot operator, and we use the operator to access the methods to modify lists. Yeah, and so the first one we will talk about is pop. So pop is that given a list, and actually like you may think about like a stack. We stack something up and up, and pop is like we have to find out the first one, kind of like the last one into the list. So if you don't pass in the passing something into this function, it will actually returns the last one. But if you append something, actually the pop method receives the index, like because actually pop method is to delete something. And if you want to delete something at the place 0, and then you pass in 0 to the pop method, so it will delete the value from the list at the corresponding place, and we also throw the values out if you actually if you do something like the pop method is the pop method is like to return the deleted value. Suppose I delete value from the 0th place, and then and then after deleting this value, I will return this value back. Yeah. So if you do not pass in any arguments into the parameter, and it will delete and returns the last one, which is like a stack, and you take the last one out. So suppose I have the example, A is 1, 2, 3, and B equals A dot pop. So because I did not pass in any arguments into the pop method, so it will return the last one, which is 3. But for A, this list, I will actually delete the last value, 3. So it will be only 1 and 2. Yeah, so this is pop. And remove. The next one, remove, is actually remove an element from a list. So at this time, we do not pass in an index. We pass in the element. Suppose you have known about there is an element and then you want to delete it. So you will pass in the element into the remove method. So delete the element passed in and then return none. Yeah. For all the methods except the pop method, everything returns none, but pop returns the value, the deleted value. So remove will return none. And then before that, you have to delete the element that you want to delete. Yeah, you pass in the element and then it deletes the element for you, but it returns nothing. So they only delete the first instance from 0th place. What does it mean? Suppose I have 1. So I have 1 at the 0th place, and I have 1 in the 2nd place. And if I want to do remove A dot remove 1, so it will only remove the first, the one at the 0th place for me. Like it goes from left to right, goes from 0 to -1. So it will delete this one for me. If you want to delete the second one, you have to do this again. So I say A dot remove 1. So A that only gives me 2, 1. Like it does not give me only a 2. It gives me 2 and 1 because it only deletes the first instance that passed in. So the next one, insert. Insert, it takes in 2 elements. It takes in the index and also the element you want to insert in. So you want to insert something into a list. So insert list pass in at the index and return none. Yeah, it also returns none. And the element can be anything. Suppose you have an integer, maybe a string, maybe even a list, and it can be accepted. Yeah. So suppose I have still this list and A dot insert. I want to insert 1. I want to insert 0 in the list, and the place will be the first place. Like, yeah, the first place is actually the second place though in mathematically. So I want to insert 0 between 1 and 2. So 2 is the first place of A, and 1 is the 0th place. And this means that I insert 0 in here, and I move all the stuff back up, back 1 place. Yeah. So A dot insert 1, 0. So which means that A will be 1, 0 to 1. So that's insert. And it also returns nothing. Yeah. And for insert, what about adding something at the end of the list? For here, we have 2 methods. One is called append, and one is called extend. So we will talk about append first. So for append, we still add in an element, like add the passed in element at the end of the list, also returns none. Yeah. And the element can be anything. Like, as I said, it can be an integer, it can be a string, or it can be a list. So So A is 1, 2, 1, still the list. And when I do A dot append 1, so it appends at it adds the element at the back of the list. So which means that A will be 1, 2, 1, 1. So it just append this one to the back. Yeah. Um, and what about a list? A list though, like suppose I want to have A dot append, say 1, 2. So will it be 1, 2, 1, 1, 2? Will it be this one? Yeah. Um, actually no. Like actually, it will be something else. Suppose I want to do A dot append 1, 2. It will be 1, 2, 1, 1, and the list. Yeah. It's actually not a list. It's actually a pointer stored in the place and pointing to the list 1, 2. But like for convenience, we'll write like a nested list. So as I said, the element can be anything. So, but for append, the only you can think about it like that, like this. Suppose like I already have a list, and then I will add a new place. And if you pass in any element, I can only like store this element into this place. Like usually you think like and a list with two elements you take up two places. But for append, no. Like I only have one place for you to store. So which means that I will store pointer. So I will store pointer once you hit this pointer, and you will be leaded to the list. So append will be like this. Append is like you can have anything here, but I only have one place for you to store. So if you want to append the list and you do not want nested list, you have to do append twice for this instance. So you do a dot append 1 and then a dot append 2. So each time you will the list will have a new place and store a new element. Yeah. But for a list, here, obviously, you do not have enough space. So it would be a pointer pointing to the list. Yeah. So this is append. But we also have a method like we only accept lists, but we can extend the list so that you do not have to do append twice. So which is extend. Yeah. Extend is to add the passing element at the end of list returns none. But the passing item can only be list. So you cannot pass in something else. You only have to pass in list if you want to use extend. Yeah. So I want to extend 1, 2. It will just be no nested list. The members of the list 1, 2 will become the new members. They both become new members of the new list. So there will be no nested list. Yeah. So this is extend and append. Append can append. You can add anything at the back of the list, but each time you only have one place for you to store. For extend, you can only extend. You can only pass in the list into this method, so it can make the list longer. And but you only have list. You can only make a list there. Yeah. And the question is that how is environmental diagram looks like for the list? So I have list and pointing to the object list 0, 1, 1, 2, 3, 5, 8. Yeah. Suppose I have two instances. So for this one, I do append 5, 6 and extend 5, 6. So we will talk about that like append is like I can only free up, I can only add a place, and I have to store the whole list. So instead, I will store a pointer. So instead, I will store a pointer at this place because you only give me one seat for me to store the list. I don't have enough space. So I will only store pointer, but once you hit me, I will lead you to the list object 5 and 6. So this is append. So what about extend? Extend is like if you are list, I can give you enough space so that you can be added into the list. So for the extend, there's nothing else like uh this is the part of the old list and this is the part of the new list. And for new list, it just be added into the end of the old list. Yeah, because I will give you enough space for you to store the for you to store 5 and 6. Yeah. So append list is actually store pointer in the modified list, and the pointer will be pointing to another list, like the appended list, like the list that pass into the append method. Yeah. So next one, we'll talk about copy list. Okay. So if I do list2 equals that one, what will happen? So this one is this function, is this, and list2 is this one. List2 equals to this one. That seems like a sign. Like that seems like when you do A equals 1, then B equals A, and B will be 1 as well. But for here, it works similar like this, but very different. Oh, wait. Suppose I still have this list in the environmental diagram, and okay, I'll do this two and this one, but it will be like this. So obviously, as you see here, this one and this two both point to the same list object. So there would be a problem. Suppose I want to do this one dot remove. Suppose I want to remove 8. So obviously, there will be no 8 in this one. But once you want to do this two, you also find that there will be no 8 in the new list. Like so the things will be like that. So which is that actually when you do this one equals to the list, it will store a pointer. It will store a pointer pointing to the list object. For list two, it will also be a pointer. So the pointer will be pointing to the same object. But I want to have two separate. I want to have a duplicate of the list object, not the pointer. So this obviously does not work for the situation that I want a new duplicate of the previous list object. So how can we make a duplicate that if I want to modify list one, list two will not be affected? So this is the problem we are going to talk about. So for here is the same object, like we both point to the same object. So this is not a copy. You can say this is a copy of the pointer, but this is not a copy of the list object. So how can I make a copy of the list object? So I have the hems here, and these are called slice. So I will do slicing to make a copy of the list object. So for slicing can copy all of the list or part of the list. Like suppose I give you a hand, and then you can cut a piece. And suppose I cut two pieces, and for one piece, for the second piece, it may be the same of the first piece, or maybe it would be smaller or be larger to the first piece, and this will be also the same situation here. So I will have the formula. So this I have start, stop, step, and separated by two columns for each one. So when I do a duplicate of a copy, this like start and stop index are all index you want to pass in. Like suppose I want to copy starting from 0th place, I would say start is 0 and stop at the second place, and the start will be 2. And so 0 and 2 are the indexes of the list you want to copy from. So So I have this 0, 2, it will copy from 0 and then 1, a stop in front of 2, which means that we do not include 2. And for step, we can actually jump. Suppose I don't want to have the indices which is even. So I would say step is like I may copy from 1 and to maybe 4, and then step is 2. So I will start from yeah. So I will start from 1 and then I will jump 1 to 3, etc., etc. So this works like that. And I call this 3S principles. So if you want to jump or if you want to only copy from a specific start, not from zeroth place, and also the stop, not from the last one, not from the negative one, and you can copy part of the list. Or you can jump. If you jump, you can only obtain part of the list, part of the duplicate of the list, or duplicate of the part, only some parts of the list. So which means that like when you slice a ham, you must be smaller than the ham that has the whole list. So what about when I want to copy the whole list? Suppose I have 1, 2, 3. I also want to copy all 1, 2, 3. So we do not use this, but instead we just use square brackets and we include the column. When we do this, if all this I have 1, 2, 3, and the new list will also be 1, 2, 3, but we separate, but we have a new duplicate of the whole list. Yeah. So the first principle, list start stop step. Yeah. So suppose I have this. When I do this one is this one from 1 to 3. So I will have 2, 3 because let's make a mark 0, 1, 2, 3. So I will start from 1 and include 1, but I will exclude 3. So I only have 1 and 2 because I will stop in front of 3. Yeah. So when I do list 3 is this one, column 2. So um, we will skip all the indices because actually we start from 0 because we start from the 0th place. So actually we only obtain indices that is even because this is 2. If you have 3, they will see the index mark 3 will be 0. Only in this situation, you can copy the elements of the list. Yeah. So the step is like to jump from 1, jump into 3, and jump into 5, jump into 7, then end. Yeah. So if you don't want to actually like talk about start or stop, you don't have to write anything at a place, but instead you should use column to separate them. Yeah, to showing that I want to use the step. I don't want to use start stop. Yeah, I want to use only step. So for this one is start from index 1, stop in front of 3, including 1 but excluding 3. Yeah, we don't want index 3. So for another one, we have include all the elements whose index mod 2 equals 0. But when you start from 1, yeah, we can do a demonstration. Yeah. It includes all the elements whose index mod 2 is 0. Yeah. So we only get the elements whose index mod 2 is 0 for here. Yeah. So suppose I give the list A is 1, 2, 3. Oh, here's another situation. So so before we used this one, like A plus equals B. So if you only for integer, that means A is equal to A plus B. For here, yeah, A plus equal to is the same as A equals A plus B, but that's not the same in list. If you do A plus equals to 4 and 5. That means you extend the list to your previous old list. So A will be 1, 2, 3, 4, 5. So, but again, if I have a new list B equals A plus 6 and 7, like A is 1, 2, 3, 4, 5 for here. So A is renewed, and I also have a B. So B is actually creating a duplicate of A. It's actually creating a duplicate of A. So um, so for here, A and B will be different, and they have different duplicates. So when I do B, it'll be 1, 2, 3, 4, 5, 6, 7. So B is A plus this one, but A still be the same, 1, 2, 3, 4, 5. So this can be treated as A plus equals another list, and B equals A plus another list. Although they are actually the same in the integer algorithms, but they are totally different when you use them in the list situation. So A plus equals list is like extend the list to the old list, but B plus A, B equals A plus list. That means um, the A will be still the same, but B is like I have an A duplicate, duplicate from the list A object, and then I extend a new list into this old duplicate, and then it will be a new duplicate. But part of the duplicate will be the object A, and part of the duplicate will be the object list. Yeah. So that's like this is like this. Yeah. So this is copy and list. So I have a practice to heap sort a list. So heap sort is actually I for here it's actually a data structure, but the concept is like I will have a list and then I have to find the highest one and then take it out, or maybe lowest one of the list and take it out and go to be a new list, and then I'll take the second greatest of this and third greatest and this until it becomes ascending or descending order. So suppose I have 5, 3, and 2. If I want to do heap sort in ascending order, I will. Oh, I can find other. Yeah. For example, I have 4, 5, 3, 2. So if I want to do heap sort, so in ascending order, so I will take out the smallest one from this list. So there will be 2, and then I will remove this. And then for the next one, oh, this is a new list. I remove from the old list, and I'll still keep exploring the list one in the old list. And the second list one is 3. Remove 3, and then get to here, and then find the third list one. So I have 4 and 5. So 4 is the third list one. So I append forward and remove 4 from the old list. And last one, I only have 5. So the last list one. So 2, 3, 4, 5. And this is the like a brief introduction or a brief explanation of a heap sort. So this was to find the greatest smallest one that is put in the beginning of the new list, by the second, third, fourth, fifth, until the last one. So for the new list, you just return the new list, and then you will get the sorted list. Yeah. So so for here, I do heap sort a list and returns a new list in ascending order with recursion. Yeah. So we have to do in recursion here. So for example, I have a bunch of numbers in a list for input, and for output, I will have all them sorted. So you can pause for a while to think about this problem, but I will still do it. I will still try to solve it for now. Yeah. So I have defined heap sort list, and then for if, this must be a base case, and for A list and 0 list 0. So A is 0 and list is the first element. Like mathematically, this is the first element of the list. Yeah. So while if, and then I have a bunch of this. So the hint is that while for here we actually to find the highest one, we will have a function called sum to find, or max to find the highest number of a list. That will be in our next lecture. So for here, we can use traditional method to find the highest number of a list inside the list. So no worries. So I'll start doing this in next. I'll start doing this in OneNote. So this is a heap saw. Yeah. So it's very like we can start from finding the greatest number of the list. So A is obviously a counter. So it can be a counter, it can be also the index of the list. So suppose I will treat the counter as the index of the list. So it will increase from 0 step by step, from 1, 2 until the last index. So we have known that the length of the list is the last index plus 1. So for A here, it will be A less than the length of the list. I'm not going to do equal because A less than length of list is the same as A less or equal to the length of the list minus 1. So the length of list minus 1 is the last index. So I just got the last index and then I'll stop. So this will be the counter, and the list will store the list the smallest number among the list. Yeah. So I have this one, and suppose I have a list. The list number, suppose it is greater than the list of A, which means that, like, suppose I already have a list number, but you've got, suppose I have the smallest number, and you've got the number in the list which is even smaller than my smallest number. So I would do so I would do this equals this number. So for now, I will be the smallest number. Um, Suppose I'm actually like checking each number starting from 0th place to the first and second place, and then I would check because list for here our smallest number is uh, the the mathematically the first number of the list. So I will check it. Suppose it's the smallest one, and Um, I will check every number of the list one by one, and from this, I will check mathematically the second, mathematically the third, and mathematically the fourth, things like that. So if I found one is smaller than me, which means that I'm not the smallest, and then I will be and then the number which is smaller than my smallest number will be my new smallest number. So I found one even smaller than me, so I will be you. So I will be smallest among my previous all. And then I was still checking it. If I found even smaller than my smallest number, I will be you. And then I will be smallest one among the new all. etc. until I got all the lists and I will be the smallest one of the list. So if not, if my number is still the smallest number, I will check the next one. So I will narrow down the counter by +1 every time. Yeah. So start from 0 until the last digit, until the last index of the list. Yeah. And then after finding, suppose I have 1, 2, 3. Like suppose I found 1. After finding the smallest number in the list, I will remove it. So I will keep finding the smallest number in the remaining numbers until I only have one number. So okay, so I will do list remove. I found this list like the smallest number, so I will remove this number because I can take an element. I can take an element in the remove function. I don't have to figure out the index, so that'll be fine. So I can use remove method. If you want to use pop, you may have to initialize another variable to keep track of your counter. Yeah. So you can store the counter though. Or you can yeah. So you should have a third variable to check if you use pop. So finally, this will be the recursive call, return. So how we use recursive call, like because we have to do aggregation, how we use the aggregation, we will use recursive leap of faith. So suppose still this one, suppose still this, like I will have another one, 3, 2, 1. I already got 1. I will go into a new list 1, and then I want to append the remaining one there. So I also want to append the second smallest and the first smallest of the list. So what should I do? I can use add. I can use plus though. Like I've talked about it in my last slide. I can use this. So it will duplicate a copy of the first list, and then extend the list. Extend the list by adding another list to the end of it, like to extend it to make it a new list. So for here, I will call this function. I will call this heap sort again. Heap sort and take in the list because I already remove 1 here. So I will take 3 and 2 inside the heap sort function call. And then by applying recursive leap of faith, you have to know that this function call returns 2 and 3. Suppose it works very well already. So you have 2 and 3. So for now, if I do 1 plus 2 and 3, I will be 1, 2, 3, which is my goal. So I would say return the list, like I have the square bracket, and I have one element. You can think about it as actually this is a list, but the length of list is only 1. There is only one element there, but it is a list though. It is a list. Although I don't assign it with a variable name, but it is a list. And then the list plus this function call. This function call actually also returns a list, so I don't have the typeable here because they are list plus list. Okay, yeah, where's okay? And then I have heap sort, and the function call return the sorted list for me. So the only thing I do is like to extend the list 1, and then to extend this one with the sorted list. So that would be my goal. So return this plus heap sort. I'll just say HS heap sort and list. Yeah. So for the base case, what should I do? Suppose I have an empty list. I can pass in the empty list by mistake. So you should have a system to stop Otherwise, you may have a maximum recursive error like infinite recursion, or maybe you just cannot return something. So this will be the base case. If this is an empty list, so you return, I guess you just return this. Does it make sense? Does it make sense if I return the empty list? Yes, it does, because suppose I only have one, and I pass in this function, and I will have one, and the base case, I will have an empty list. Like, remember, when I do addition between lists, it will do the same effect as I use the extend method. If I use extend method, like because you don't have anything inside the list, so it will basically just return one and nothing else. But if you do append, um, if you do append between one and the empty list, it will be one and then a pointer inside pointing to the empty list. So this will not be okay, because we don't want nested list and we don't want to keep the empty list. We just want to show, oh, this is empty, and we have nothing to return. That's it. Yeah. So we use extend because the addition is extend. So this makes sense. When I do empty list and a list with only one member, and when I extend the list with only one member with the empty list, it will still be the list with only one member. Yeah. If I do none here, there will be a mistake. Or if I do zero here, can't do this because for here, it is actually the addition between lists. So you have a list at the left side, you must have another list on the right side. Like this can be an empty list, but this cannot be zero or none. That will be type error. Like you don't have object with the same data type at each side, so that will cause an error. So the answer is define heap swap list. If this is an empty list, it will return still an empty list. So, and then I will have the counter A will be 0, and then list will be the first member of the old list. Yeah, we can call this smallest. So while A is less than length of A, so I will loop from 0 to the last index of the list. And then if this is greater than, if the smallest is greater than the list, the one of the members of the list between 0 and -1, 0 and -1. So this means that the smallest number, smallest number stored in this variable is not the smallest value in this list. So I will be that smaller number, and I will keep renew again until I get the smallest number. The variable will be the smallest value of the whole list, and I will loop that by increase A by 1. Yeah, and after I found out the smallest value of the list, I remove this because I already stored the value and I want to find the second smallest. So the second smallest, after removing the first smallest, the second smallest will be the first smallest. Yeah. And then I return the aggregation. So I have the list at the front of the list, and I only have to extend other things. I only have to extend like the sorted list, and but the sorted list is in a smaller version of the problem. So I just extend this with 1. So the second smallest sorted list will be will start from the second place mathematically. Yeah. So it will be 1, 2, 3. So by applying recursive leap of faith, we have to know that the recursive call returns the sorted list, but in a smaller version. Yeah. So that's it. So if you want to see the answer, so this is the answer. If this is less than, return an A, this 0, this. But this is the answer. Yeah. I can do demonstration. I can do first. I will do pop. I'll do is one. So it will be free. And if I want to do A, B equals A dot remove. So I have one and two left. I remove one. It will be none, but nothing displayed here. And A will be only two. Only 1, 2. So under A dot insert. Insert at the first place. Yeah, like after, I think after 2. Maybe you can do 0. 0, 2. Okay. So A will be A2. Yeah. So A dot append. I have 6. What was it? So A will be A26. Yeah. How about a list 5, 6? Yeah, there would be a nasty list. And also A dot A P P E N D. How do you stand this time? 5 and 6. A will be after all this. Yeah, 5 and 6 will be all after this. If I do extend a number, there will be an error. Yeah, because they only accept a list. So append, extend, insert, remove, we do all of them. Yeah. How about copying a list? Suppose B equals A. If I do B dot remove 2. So B will be, there will be no 2 in the list. How about A? A will be same as B, although I didn't use A. Like suppose, like usually when dealing with integers, we only have when we set B equals A, when you B to B plus 1, and A will not be changed. A will not be plus 1. A will not be plus the yeah. A will not be added by 1. So, but for here we will. But we can do slicing. Yeah. When C want to remove 8, C will be, there will be no 8 there. Yeah. How about A? A will still have an A. So this is slicing. And how about we do T equals A? Start from 1. There will be 6, 5. We can think about it like for 0th place and 1st place. So start from 6. And then we will only find, we will skip 1 though, because each time you only have this, you have 2 steps. So which means you have to skip 1 each time. Yeah. So 6 and then 5. And then there will be no there. There will be no stuff there. So only 6 and 5. Yeah. D minus 1. I haven't done this. So there will be 5. And minus 2, there will be 6. Yeah. So if I keep doing, there will be an error. Yeah. Out of range. Okay. So that's it for today. So hopefully you have learned about list and mutability. And that's it. Okay. Thanks for watching this. Bye bye.